No, suppose.
Right? We understood that if we have simultaneous electric field and magnetic field, then what will be the total amount of force that will be acting on the charged particle? So this we understood in the previous class. Now let us move further and understand about where is the pen? Yeah. So now let us understand about okay. So force in a current carry conductor, right? So we already know, and there is no electric field. There is no external electric field. We only have a magnetic field, right? So you guys tell me that what is the magnetic force? What is the magnetic force, guys? Hmm. What is the magnetic force? Yeah, you guys already know the answer, but okay,
Q.
yeah, yes, Aisha, yes. Maybe
No,
your,
V into B.
yeah, Q V cross B. This is what we understood about the magnetic force, right? Okay. Now, you guys tell me that if I have a current carrying conductor, right? I have current carrying conductor, and let's say this is joined by some potential, right? So the current is following in this way, so the charges will move in this way, right? So you guys tell me that what is the speed of these charges? In a conductor, what is the speed? What is the velocity? In a conductor, current carrying conductor, what is the velocity? From the third chapter, current and electricity, the second topic that we did. Yes,
Can
guys.
you repeat what you said?
I am saying that the current is flowing in this way and the charges are moving in this way. So what is the velocity of all the charges moving in a conductor? Yeah. What is the velocity? Yes, Aisha, Mariam, we have discussed about that in detail. So when you apply some voltage across the conductor, then what is the velocity? Okay, let me simplify the question more. So what is the average velocity of charges moving in the current carrying wire? What is the average velocity of charges moving in current carrying wire? Okay. Yes, drift velocity, right? Absolutely right, Aisha. So this is the velocity with which the charges move. Understood? So the charges are moving with drift velocity. Good, good. Now you guys tell me that we have to calculate the total charges which are flowing in this volume. So this is a cylindrical wire, right? This is the area of cross section is A, and this distance is D. Okay, or let me write it as L. Right. So this is the length of the wire. Okay. Now in this volume there would be charges, right? So the total charge would be what? This would be total volume, right? Total volume into number density, actually. Number density, right? This would be total charge. So, and let's say one charge is Q, right? So these would be the total charge. Understood, guys? Is this clear?
Yes.
Yes.
So total number of charges is this, and one charge is carrying this much amount of charge, right? So this is charge on one particle, and this much number of, so this is capital N, right? So the total charge would be how much? This is Q, and volume is area into length, and number density is N. So this is my total charge, right? So now you guys already know that force is what? Force is Q Vd, right? Because velocity is d cross v. And we know that Q is how much? Q is Q and N, A, and L, and this is Vt, right? And then into V. Okay. So I if I ask you this, that what is N Q A V T? What is this?
Current,
Yes, what do you say, Aisha?
current I.
Current. Yes, absolutely correct. So we learned about the relation between current and drift velocity. Good. So this means that you are revising. So in that way, I wrote this like this: NEAV. Right. This was the expression that we derived. So similarly, Q is E is Q. So we have this is current. So this will change to uh, this is I, and then this will become vector L cross P. Right. So this is the force. Now let's say that the magnetic field who got disconnected. Oh, so everyone is right. So let's say that the magnetic field is in this perpendicular, so inside the right. So this is the direction of the magnet. Okay, L is in this direction. This is L. Okay, or I should write it in this direction because current is flowing in this way. So L is in this direction. Magnetic field is inside. So what would be the angle between L and B? What would be the angle between L and B? So magnetic field is inside, right? And L is in the right direction. So this is right and this is inside. So what is the direction? What is the angle between L and B? 90 degree, right? So this would be what? I L B sine theta. So sine theta is sine 90. So F would be BIL. So this is the force, right? Acting on, so we had this magnetic field, right, which was inside, and then this current carrying wire. So this current carrying wire will experience some force, and this will change to this QV cross B will change to this one, BIL, right? So this is the force of current carrying wire. Is this clear to you guys? Is
Yes.
this a, okay. So now you guys please note it down and then we'll do one question. Oh, Saad has just any doubt. If you guys have any doubts, so please ask. Right. If you guys have any doubts, so please ask. Yeah. So did Saad join? Yes. Hello, Saad. Assalamu alaikum. Hello, Saad. Can you hear me? Yes. Saad Sahab. Yes. Saad, can you hear me? Oh, yes. So we just discussed the force. So we were just in the previous class we discussed about the Lorentz force. Now we are understanding about the force in a current carrying conductor. So we have this magnetic field which is inside, and then there we have placed some current carrying conductor. This will experience some force, and that is QV cross B. So this will change to BIS. This is what we have discussed. Okay. So please note it down, and whenever you guys want me to scroll down the screen, you guys it. Okay.
Okay, so
Yeah. So whenever you guys have noted it down, please tell. And if you guys have any doubts, so please ask. Then Mayam and Saad noted.
Yes, sir, done.
Okay. So now let us quickly do one question and then we'll so what is yeah. Okay, Saad, yeah. So what is the magnetic force experienced by the current by the wire carrying 5 ampere current of length, let's say 1 meter in the presence of magnetic field 10 to the power 4 Tesla. Right, so this is the question. And the directions are like this. So we have this current carrying wire. Right, this is the current carrying wire, and the current is flowing 5 ampere current as well. Right, so this is the direction of L. Okay, and the magnetic field is this, which is this is the magnetic field, which is 10 to the power 4 Tesla. Okay, and we have to find out what is the magnitude of magnetic force. So what do we actually know? What do we already know? That force is BIF, right? So B is, but we have to first find out that what is the direction between L and B. This is important. So this is actually BIL sine theta, but L is in this direction and this is cross. So what is the angle between L and cross? So this question is for Saad. We have, so we have this magnet, this wire, current carrying wire, which is going in the right hand direction, in the right hand side. This is going right, and this is the direction of the magnetic field. So this is actually inside, but this will appear to be outside for you guys, but this is actually inside. Okay, so for my point of view, this is going inside. Okay, this is going inside, and this is, so what is the angle between these two? Right. So this is the angle between these two, 90. Okay. So the angle is 90, so we can simply put BI. Yeah, so this is BIL, and B we know this is 10 to the power 4. I is 5 ampere, and L is 1 meter. Right, so this would be how much? 5 into 10 to the power 4 Newton. This is the force. Clear, everyone? Or do you guys have any doubts? Yeah. Is this clear, or do you guys have any doubts?
Yes, sir.
Okay. So if it is clear, then I'll ask you one question. So L is, right. L is, what is the direction of L? Or I should write, direction is represented by hat. So what is the direction of L hat? Yes. Who's going to tell me? The direction of L hat or direction of L? Yes, guys. Direction of L hat. X-axis, right? So you are right, I just Y. This is I, right? So direction of L hat is I hat, okay. And what is the direction of magnetic field? What is the direction of magnetic field?
J hat.
J. So this is inside, going inside. Yeah, this is going inside,
K hat.
right? K
K hat.
or minus K hat. Outside is K hat, right? Inside is minus K hat. And then you guys check that what would be the direction of L cross P. The direction of L cross P would be I minus cross K. So I cross K is what? What is I cross K? What is I cross K? Yes, I cross K, guys. We are going anti-clockwise or clockwise.
Clockwise.
This is clock. We are going I cross K,
Anti-clockwise.
anti-clockwise. So what should be here? I cross K is J. J or minus J? What
Minus J.
minus J, right? So minus J. So this
Sir?
is, yes.
Sir, can I rejoin in some minutes? I'll rejoin in 5 minutes.
Okay, okay, okay. No worries, no worries. So this is the direction of force, right? And yeah, and if we check it with the Maxwell thumb rule, right? So if we check it with the Maxwell thumb rule, so if we put our palm, right? So if we put our palm in the X direction and palm is pointing towards the inside direction, right? So palm is pointing towards the inside direction if we curl our finger. So what is the direction that it is giving? You guys check and tell me. So from Maxwell's thumb rule, what is the direction that we are getting? This is, yeah, what did you say, Aisha? I can. So you are in the upward. Yes, upward is what? J, right? Upward is J, right? Yeah, absolutely right. So from the Maxwell thumbs rule, we also saw that the direction would be J hat, right? So both the condition. So from the Maxwell thumb rule, we also got the same direction. Clear, everyone? Saad, understood? Yes, Saad? Oh, so you have three. Okay. Now let us move on to. So did you guys note down this problem? Yeah, did you guys note down this problem? Okay, please note it down and then in the meanwhile, maybe Mariam will join. So please note it down. And whenever you guys have noted it down, please tell. Noted, everyone? Saad, what about you? Oh, you have not noted it down. So please note it down. Then I will ask you guys one question and then we'll move on to the next topic. Noted, Saad. Yes, Saad. Noted. Okay. Oh, who is it? Oh, Mariam. Now, if I ask you guys that, let's say, you guys should tell me directly the answer. So let's say that the magnetic field is in this direction. This is the magnetic field. Yes, Mariam. So we are just okay. So you didn't miss anything. We were just talking about that problem. Okay. Now this
Yes,
is
sir.
this is the direction of magnetic field, and I put my wire in this direction. So this is my wire. Okay, and the current is flowing in this direction. The current is flowing in this direction. Okay, so L direction is this. Magnetic field also is in the same direction. So can you guys tell me what would be force? Or let me ask you the magnitude. What would be the force? I have not given you the value of magnetic field and length of the wire. So I am asking that what would be the magnitude of the force, right? So what do you know, guys? You know that F is BIL sine theta, correct?
Yes, sir.
Correct. And what is theta? Theta is the angle between L and B, right? This is the theta. So what is the angle between L and B in this case?
0.
0. So sine of 0, right? Good, correct. This is okay. So whenever you get the magnetic field and the length of the wire in the same direction, then magnitude of force will be 0. Understood? Clear, guys? Yes, guys, clear, or do you guys have any doubts? Clear, everyone?
Yes, sir.
Okay, so now let us do the next topic, which is force between parallel current carry wire. This is a very important topic. This topic defines what is 1 ampere current. Okay, so from this, uh, this was from this property in 1946. People defined or people gave the definition of 1 ampere, right, using this property. So this is very important, right? So the definition of 1 ampere comes from this property. So let us talk about so we have two. Oh, so yes. Can you scroll up for 1 minute? Oh, So this one.
Yes, done, sir.
Then okay. Yeah. So the yes, we have wires. So and these are in the same the direction of current is in the same direction. Okay. So there are no any external field, right? There are no any external field, but in this case, we had the external field, right? This was the external field in this case. But for our case, in the parallel current carrying wire, we don't have any external external magnetic field. So, which part will provide the magnetic field, right? What do we know about the current carrying wire? We know that from Biot-Savart's law, we know that they will have some magnetic field. Correct, guys? Correct.
Yes.
So if I ask you that, let's write the separation between them is D. Okay. So let's write that separation between them is D, and we are okay. So we'll talk about that later. But do you guys remember that what is the magnetic field of an infinite wire at this point? Do you guys remember if this is the current? What was the magnetic field? Let's say that this is A. So what was the magnetic field?
Mu naught I by 2 pi.
2 pi A. Absolutely right. Good. And what was the direction at this point? Yes. What was the direction at this point? Whenever we talk about the direction, just remember the Maxwell thumbs, right? So we put our
In
inwards, right? So we put this is the current, and we are calculating in the right hand side. So we put our finger, our thumb in the direction of current, and then we curl our finger. So this is going inwards, right? So in the right hand side, it is inward. In the left hand side, it is outward. So always remember these, right? Okay. So we have at this point, right? So uh, this current carrying wire will have some magnetic field at this point. So this will have this magnetic field at each point. Right. So let me write that. Let me take this step. So this is the length I am taking. Right. So this is B1 magnetic field due to this one wire. Is this clear up to this point? Clear up to this point, guys.
you can explain again.
Yeah. So we have this wire, right? We have this wire I1. This is I1, and at this point we'll have the magnetic field in the inward direction. At this point, again, we'll have the magnetic field inward direction. Same, right? At this point again, and at this point again, and at this point again. So we have a constant magnetic field at this line, right? At this point, we have the magnetic field in the inside direction. Let us take this much length. Clear? Is this clear? Clear due to this current carrying wire. Clear? Is this clear, guys?
Yes.
Okay. Now we have this magnetic field. Now we have the external magnetic field, right? So we have this external magnetic field, and we have this I2 current. So I2 current is in upward direction. The magnetic field is in the inside or downward or the inside direction, right? So this is upward and this is inside direction. So the force would be how much in this length? What would be the force, magnetic force? Yes, guys. What would be the magnetic force? What is the magnetic force of a current carrying wire? What is the magnetic force of a current carrying wire? PIL, correct?
Yes, please.
So we have this current which is flowing I2, and we have this external field due to this current, right? This current is providing the external field at this point. So the magnetic force would be V1, right? And I2 and this length L. If I am wrong, please correct me, guys. Is this point clear? Is this point clear, guys? Is this point clear?
Yes, please.
Okay. So this is force on I2 current due to I1 current, right? This is F21. And B1 is how much? This is mu naught I1 by 2 pi t. Okay. And this is I2 and then L. Because B1 is how much? B1 is mu naught I1 by 2 pi t. Right. This is the length and this is the current. So this is the magnetic. Okay. So the force due to 2 on 1 would be mu naught I1, I2, L by 2 pi. This is the force on force between parallel current carrying wires. Is this point clear, guys? Is this point clear?
Yes, sir.
Okay. Now, who will tell me the direction of the force? Who will tell me the direction of the force? So everyone think about the direction. Remember, direction is L cross B. So you guys either use the IJK method or the simple method that we can use is Maxwell's thumb. So you guys tell me what would be the direction of the force. Yeah. What would be the direction of the force? Hmm. Anyone got the answer? Right, left, up, down, inwards, upwards, inward or outwards?
Outwards.
Outwards. So you are saying that the force is outwards. Okay, so Mariam is saying outwards, and Saad is saying right. And Aisha, what about you? Remember the direction is L cross B, right? So either you use IJK method or you use the thumbs. Yes, Aisha, what is your answer? Don't bother about the right and wrong, right? So tell me your answer. Yes,
Outwards.
outwards. Okay, so Aisha is also saying outwards. Aisha is saying outward, but now Mariam has changed her answer to J is upward, right? So Mariam, now you are saying upward.
Yes, sir.
So which one is correct? Okay. So first, let us use the right hand thumb, right? So we have what? So we have this current. This is going upwards, right? So this current is going upwards, right? This is in J direction. Okay. So this is in J direction, and what we do is that the magnetic field is inside, right? Magnetic is inside. So we place our palm, right? We place our palm in the magnetic field direction. So this is our L, and this is our magnetic field. So if we curl our fingers in the magnetic field direction, so what is the direction that we are getting? What is this direction, guys?
Left.
Left. Okay. So
Like
this is left direction, right? This is F21. So this is minus I. Correct.
Yes, sir.
Okay. So Saad, Aisha, understood.
Yes, sir.
Okay. Now let us check with the this IJK method whether we are correct or not. So this is uh, magnetic field is, yeah. So okay, magnetic field is minus K, right? And this is L is J. So L cross B, right? L cross B is J cross minus K. So minus J is outside J cross K. So what is J cross K, guys? What is J cross K? This is clockwise. J cross K is what? Yes, guys. What is J cross K? Yeah, yeah. What do you say?
I
I,
have
right? I. So this is minus I. Correct. So this is also yeah, this is correcting this one, right? So this is justifying our answer. So which means that this is the force which is applied. So this I1 is applying the force in this direction. So this is attractive or repulsive? This is attractive or repulsive, guys? Yes, guys, attractive or repulsive? So this is I1 and this is pulling it in itself direction, right? So this is attractive. Similarly, if we calculate F on magnetic, so magnetic force on 1 due to 2, So this would be minus of F21, right? So this would be F2, F1. You guys think about it. So similarly, whatever we did in here, so you guys do it here. So then we get this magnetic force. Okay. So you guys can see that these are pulling each other in their direction. So this is attractive force. Attractive force. But when the currents are anti-parallel, anti-parallel meaning that one is going in this way and the other one is going this way. So then force is repulsive. Okay. So any of you guys have any doubt up to this point? Yeah. Any doubt up to this point, guys?
Not so.
Okay, so please note it down and then we'll talk about. Yeah, so then we'll go ahead. We'll do some question and then we'll go ahead. And if you guys have any doubts, so please uh, don't hesitate to ask me any question. And whenever you guys want me to scroll down, then see you guys. Yes, whenever you guys want me to scroll down, the see you guys. Noted, guys. Should I scroll down? Whenever you guys have calculated, please tell. Quickly note it down, guys, quickly. Noted, everyone.
Done, sir.
Saad and Mariam, what about you guys? Yes, Saad and Mariam. Saad has noted. Mariam, what about you?
Done, sir.
Okay, so now we understood that if we have two parallel current carrying wires, right? Then the force applied at here, right? So magnitude of force would be mu naught I1, I2, and L divided by 2 pi. This is the force. Now there is another thing which is called force per unit length. Force per unit length. So how it is defined? This is F by per unit length, which is L. So this is F, right? This F, small f. This is force per unit length, which is mu naught I1, I2 divided by 2 pi. This is the force per unit length. And what would be the SI unit? So SI unit would be Newton per meter. Okay. So now, what is the definition of 1 ampere? This was given in the 1946, right? And they defined the 1 ampere like this. So 1 ampere is defined when so when two parallel current carry wires of equal magnitude separated by 1 meter distance, right? And experiencing 2 into 10 to the power minus 7 Newton per meter force per unit length, then the amount of current each wire are carrying is called 1 amp. Okay, so we can see that what is the meaning of this. So it says that both the currents are carrying equal amount of charges. So this is I, this is I, and the separation between them is 1 meter. So let us define what we are defining. So we have two same current carrying wires, right? And the difference between the distance between them is 1 meter, right? So what is force per unit length? This is mu naught and I square, right? Divided by 2 pi and d is how much? 1 meter, right? So this is, we are calling it 1 ampere. So 1 ampere would be how much? This would be, this is F. So this is mu naught is 4 into 4 pi into 10 to the power minus 7. And this is 1 and then this is 2 pi. So this is what? This is 2 into 10 to the power minus 7 Newton per meter. This much amount of force per unit length, whenever the current are experiencing this much amount of force per unit length, so that current would be called 1 ampere. Is this part clear to you guys? Is this part clear, everyone?
Yeah.
Okay, so this is the definition of 1 ampere. You guys please note it down, and if you guys have any doubts, so please ask. So this was force per unit. There. Okay. And from here you guys see. Whenever you guys want me to scroll down the screen, you guys
We can stop.
whenever you guys have completed, please tell. Noted, everyone?
Answer.
Done.
Yes, sir.
Saad, what about you? Yes, Saad. Noted. Okay. So now there is one question that I want you to try first. And I will discuss this in the Saturdays. So on Saturday, I will take an extra class. So on Saturday, I will discuss this question. Right. So we have this current and we have this loop. So in this loop, the current is flowing in this. Right. So this is again I. This distance is d. This is length and this is b. So you guys have to find out what is the force experiencing by this loop. So force experienced by the loop. Okay. So is the question clear to you guys? So you guys can see that these are parallel, these are perpendicular, right? And these are again anti-parallel. So you guys have to figure out the force. Okay. Yeah. So this is the question. You guys, let me tell you. Let me write it like okay. Clear, guys?
Yes, sir.
Yeah.
Yes.
So please note it down and try this question. So next topic is magnetic moment of a current carrying. Okay. So when I say magnetic moment, so can you guys recall? Did you guys came across this moment thing in the previous chapters? Did you guys
Yes.
come? Yeah. What was that?
Bible.
Absolutely right. So whenever we had two charges, right, of equal amount separated by a very infinitesimal distance, two-way, then they experience some dipole moment. What was this dipole moment? Yeah, what was this dipole moment?
2AQ.
2AQ, right? So 2AQ, which was the separation between these two distance and then the charges. So this is A and Q. So this is distance into charge. This was the dipole, right? This is distance and charge. Similarly, we have magnetic moment. So in the case of dipole moment, we had distance. But for the case of, because we are considering a loop, so the loop will have an area. And there is charge, so charge is replaced by what? Current. So this is the, right. This is the magnetic moment of a current carrying. And if it has n terms, so this is this part clear to you guys? Is this clear?
Yes, sir.
Okay. Okay. And the, as you can see that the SI unit would be how much? So SI unit would be ampere meter square, right? Ampere is current and area is meter square. So ampere meter square. Okay. And what is the direction? direction of the current carrying loop. So let's say that we have this current. So this is going like this. And let's say we have this current. So the current is going like. So again, using the thumbs rule. This thumbs rule is very important. Maxwell's right hand thumb. Right hand thumb. So we have this right, this current carrying wire. What would be the direction of magnetic moment if we use the Maxwell's thumb rule? What would be the direction? Yes, guys. What would be the direction?
Inward.
Inwards, right? So this is inwards. Good. So we have inwards magnetic moment. And in the case of air, what would be the direction of magnetic moment? Outwards, right? So this is what we call the magnetic moment. Okay, so let's say that if I ask you that we have this circle, right, and the radius is, let's say, r. Okay, and the current is flowing I. So what is the magnitude of magnetic moment? What would be the magnitude of magnetic moment? This is NIA. N is 1, I is I. Area, what is the area of the circle?
2 pi r.
Area. Right. So this is pi r square I and ampere meter square. So this is the magnetic. And let's say that we have this kind of, okay. Then what would be the magnetic moment? Again, N I A. So the current is flowing I. And N is 1, I is I. And let's say that this is breadth and this is length. So this would be L. Right? So the magnetic moment would be how much? LBI and ampere meter square. So this is the magnetic moment. Is this clear, guys?
Yes, sir.
Okay, so note down up to this point. And if you guys have any doubts, so please ask. This part you already noted, so note down from it. Do we have an assessment today? Yes, yes. So we have an assessment. Yeah. So after this class, we have an assessment, guys. Whenever you guys want me to scroll down the screen, guys,
Done.
yeah. Then please note down this question.
Done, sir.
Okay, good. So now the next topic is okay, so the next topic is torque on current carry. Okay. And before that, I will study the force on current carry. Right. So we have current, right, which is flowing like this. So this is the current. Okay. And then this is the direction of the magnetic. Okay. So the direction of magnetic field is in which axis?
X-axis.
X-axis. So the direction of magnetic field is in X-axis, and this loop is in which plane? This loop is in which plane? Yes.
XY.
Yeah. So X is this direction, right? So this is this in the X direction? So this is in YZ.
Why is it?
Yes, this is in YZ. Right now we have to calculate what is the force acting on this loop. Right. So we have to figure out what is the force that is acting on this. So the dimension of this loop is, let's say this is L, and or this is B. Right. So this is total area is L into B. Okay. So let me summarize the direction of yeah. So we have this, right. So this is the area, right, and this length. So this length is B, and this length is L, and this is in YZ plane. So this is Y, and it is coming outside, right? So this is in YZ plane, and this is X-axis, right? This is X-axis. So you guys tell me that if I consider this direction, right? So if I consider this direction, the upward direction, and this is my magnetic field, so what would be the direction of force? Yeah. So this is in the, let's say this is in the, let's say this is what? K hat direction. This is K hat direction, and the magnetic field is in the X direction. So what would be the direction of the force? You guys tell me. You guys figure out and tell me. Right. Okay. So Mariam is saying in the right direction. Okay. So Mariam is saying in the right direction. For, let's say, let me write this side. A, B, C. Okay. So for, for, For AB, Mariam is saying right direction. And Aisha, what is your answer? Shad, what is your answer? Yeah, Saad, what is your answer? Aisha, what is your answer? So you have again, remember where is your L, right? So remember where is your L and where is your B, right? So where is your L and where is your B? Okay. So this is how the this is how the current is flowing. Okay. So these uh, these direction are pointing out in the Z direction. Okay. And your palm is pointing out in the X direction. And then you are curling your finger. So what is the direction that you guys are getting? If it is clear or not. So you guys tell. Okay, what is the direction that so Aisha or so Mariam is saying right. Okay, this is the direction of the current or length, right? So length is K hat, right? Up. Okay, Mariam, you have changed your answer. So Mariam has changed her answer to up. Okay. What about Aisha and Saad? Do you guys have any questions? So if you guys have any doubts, so you guys can ask. Right. So let me clarify this question to you. So we have this magnetic field. Magnetic field is in the x direction, and my this is my YZ plane. So the current is going in this direction first, Z, and then down, which is Y or which is minus Y, and then minus K, and then Y. So this is how my current is flowing, right? And then the direction of magnetic field is in this direction. So you guys think about it. So first is this direction. You are pointing out these four finger in the direction of DL, and then you are curling your finger in the direction of magnetic field, which is X, right? So your palm is directing towards X axis. Then this is the direction that you are getting. So Mariam is saying up, and what about Saad and Aisha? So Aisha has got the same answer. Aisha is also saying upwards. Saad, what about you? If we don't know, then we can use this property. So L is K hat, B is I hat, right? So L cross B. L cross B will be where? Saad boss, L cross B would be where? I, J, K. So K cross I. What should we, what we'll get, Saad? Yes, Saad. Minus I. Hmm. So K cross I. K cross I. What is K cross I? J. Mariam is saying J, which is upward, right? Yeah, yeah. K cross I. Remember, this is K hat, right? This is K hat and this is I hat. So K cross I. K cross I is J hat, right? Okay, so we will stop it here, right? And I will discuss this part. So only two topics are remaining. This one and then moving coil galvanometer. So I will quickly finish these two and then we'll do the next chapter. Okay. So you guys think about it. Do this problem, then you guys will be able to answer, right? So do this problem, and then you guys will be able to answer this. Okay. So you guys log into your Learnivio account and then see the active test. Okay, so Rifa has. Did you guys got the? Did you guys get the active test? Yes.
Yes, sir.
Okay. So if you got that, then you guys can leave, right? So you guys leave and then complete that test. Okay. Allah Hafiz, guys. Allah Hafiz, Aisha, Maryam, and Saad. Bye, guys.
Yeah.
Yeah,
Love it, sir.
please complete that test, but right. Allah Hafiz, Allah Hafiz. Yes, Saad. That for you the test is not active, but Mariam got the test. Okay, so we'll see. Did you check again? Yeah, did you check again, Saad?